All right, now we've got another problem where we're looking at, we've been given data, and so we want to figure out how to model this with a linear equation. So now we have our day, which we're using the variable n for, and it looks like we're using h for our height. So we've got a plant for a science experiment, and we can see that we're going every 3 days, the height of our plant increases 1.5 centimeters. So we can see that our rate is going to be, remember we've got change in y over change in x. So height is our independent variable and, day is our independent variable, height is dependent on what day it is. So this goes up by 1.5 as our day goes up by 3. So we can simplify this. That's going to be 1 over 2, which is the same as our slope. Now we don't see the starting day on here. We don't have day 0. So we've got a couple of ways we could figure that out. I think the easiest is this is always going up by 3, up by 1.5. So we could go the other way and say that if we go down by 3 and get to 0, that would be our starting day. Go down by 1.5 and that would give us 2.5. So we can see that on day 0, the height is 2.5 centimeters. So that's our initial value. This is then our y-intercept. So if I start by just writing my equation y equals mx plus c, then I'm going to get, here I have 1 over 2, here I have a decimal. I want to make sure to have only decimals or only fractions. So this is easy to turn into a decimal. So 0.5x plus my initial value was 2.5. Now I want to make sure and use my variables from the problem. So height depends on what number the day is. So now instead of x, I've got the number of days plus 2.5. So here's my final answer for my linear model. All right. And now determine the height of the plant on day 37. So n is 37, h of 37. So what my height is on day 37, 0.5 times 37 plus 2.5. And we get 21 centimeters. All right, last one. How many weeks until the plant is at least 1 meter tall? Well, 1 meter is 100 centimeters. So I want my height to be greater than or equal to 100 centimeters. So for my height, I have to use the whole equation. I want to know also what day. So there's my hint there that it asks, oh, how many weeks? So we got to make sure to change it into weeks. So how many weeks? That's still a time measurement, and my time is being measured by n in days. So first I need to replace this with my equation. So 0.5n plus 2.5 greater than or equal to 100. So I'm going to solve this. I'm going to take 100 and subtract 2.5. And then I'm going to take this number and divide by 0.5. And I get that my number of days has to be greater than or equal to 195. This is days. So if I want weeks, I'm going to do 195 divided by 7. It's 27.8. So in week 28, the plant is greater than 1 meter. And when we get into class, we'll talk about how realistic this is.